Today we're going to look at the lunar cycle and tides. In the model, we're going to drag and drop the moon phases in the correct sequence. So here what you want to do is determine where is the sun and the earth. You want to sniff your moon phases. So you always want to go sun, new moon, earth, full moon. SNEF, sun, new moon, earth, full moon. So let's start with that sequence. So in between the sun and the earth, we always have a new moon. When you're on earth and you look up at the moon, you see zero illumination. You don't see a moon because the side of the moon that's being illuminated is the back side. Now the moon travels in a counterclockwise position. So over here, when the moon is behind the earth, we say it's a full moon. So again, it's sun, new moon, earth, full moon. If you're on earth and you look up at the moon, it's 100% illuminated. Okay, now with this reference, you want to go counterclockwise and name your phases. So what happens after a new moon, you're gradually going to see light on the right. This is called waxing. So we grow in illumination from a new moon to a full moon. So I want to take the image where I have a little sliver of light on the right. That's called a waxing crescent. Waxing because I'm light on the right, I'm growing in illumination, and crescent for its slivered shape. So I'm going to gradually grow in illumination until I'm full. So I'm going to grow a little bit more, and I'm going to grow about half illumination. When the moon is half illuminated, this is called a first quarter, and you can see it's directly half of the moon. More than half illuminated light on the right is going to be a gibbous shape. So more than half of the light illuminated is this gibbous shape. Notice how I'm increasing light on the right, and then a little more light on the right, I'm going to be a full moon. Okay, from this position, we're going to wane. We're going to lose illumination, and we're going to lose illumination little by little until we're new again. So after the full moon, we're going to lose light on the right now. So we're going to lose a little light on the right, okay, and you're a gibbous shape. You're more than half. If we lose a little more light on the right, we're going to be a last quarter or a third quarter where we lose half the light on the right. We're going to lose a little more than half, and then that's called a waning crescent. Okay, some key things I want to point out: that your crescent shapes are always going to be before and after a new moon. With your full moon, you're always going to have gibbous shapes come before and after a full moon. You wax, so you grow with light on the right, and then you wane, you lose the light on the right. On our next slide, we're going to use the moon identifying dichotomous key to identify each phase of the moon. Okay, so you could just name them if you know your phases, or you could use this tool that will guide you through identifying each phase. So what I'm going to do is I'm going to name the phases for you, but if you have trouble doing this, you would want to use the moon identifier up here that will guide you through steps to identify each phase. So here, for this lunar phase, it's 100% illuminated, so we call that a full moon. Here you're losing light on the right, so you're waning, and then you want to look at the shape. It's more than half, so it's a gibbous shape. So this would be a waning gibbous. In your next image, you're losing the light on the right, and you're losing half. So this would be a third quarter. Your third quarter is sometimes referred to as the last quarter. In this phase, I have the light on the right, so I'm waxing, and then I look at my shape, and it's a crescent shape. shape. So I'm a waxing crescent. Going up top, when I have zero illumination, it's called a new moon. So here I'm looking at light on the right. So if I have light on the right, I'm waxing. And then I want to look at the shape. It's a gibbous shape. It's more than half. So I'm a waxing gibbous. In this phase, you see that you have the light on the right hand side of the moon. So you're waxing. And this would be your first quarter. In this phase, you're losing the light on the right. So when you lose the light on the right, you're waning, and then you look at your shape, it's a crescent shape. So it's a waning crescent. And if you use the dichotomous key for help on these, you would just describe how that dichotomous key worked for you. In this activity, we're going to drag and drop the correct moon phase from the bottom into each box to complete the moon phase sequence. So we're going to go from left to right. So when you look at this moon phase, you want to look at, well, where do I have light? Since it's light on the right hand side, you're always waxing. And then you look at the shape, which is a crescent. So if I'm a waxing crescent, my next phase, I'm going to grow an illumination a little more, and I would be half illuminated light on the right. So I would be a first quarter. So let's bring that up. And here you can see, okay, I'm a waxing crescent, then I'm a first quarter, and then light on the right a little bit more. You're going to be a waxing gibbous here. Let's look at this image here. So this is giving us the hint that we're losing light on the right, so we're waning. So after the third, so you want to identify this as the third quarter or the last quarter. So what comes before the third quarter? Well, you're going to be losing the light on the right, and you're just going to lose a little bit of light on the right. So what you would have there would be a waning gibbous, because you're looking at the shape of the light. Okay, then we're going to lose a little bit more light on the right. We're a third. Now we're going to lose more than half, and then we'll be that waning crescent. Okay, going over to this image, we have a full moon, so we want to know what comes before the full moon and then what comes after the full moon. So right before the full moon, we're waxing, and we understand we have light on the right, and we have more than half. So we're going to be a waxing gibbous. So I have light on the right, and then I'm full. Then after this phase, I start to lose the light on the right, and I lose just a little bit of light on the right. So I would be a waning gibbous. Remember, your gibbous shapes, which are more than half, always come before and after a full moon. Okay, in this phase here, we're losing light on the right, so we are a last quarter, and I'm half, so I know I'm either first or third quarter, but if I'm losing the light on the right, I'm a third quarter. I lose a little more light on the right than a half, so this would be a waning crescent, and then I'm going to lose a little bit more, and then you go to that new moon phase. Okay, let's go to our next activity. This is a STAAR test question. We're going to look at the model below, and we're going to provide an explanation for how the model represents moon phases. Let me just stretch this out just a little bit so we can see it better. So here we're modeling the light is the sun. Okay, you are on Earth, so you are Earth. Okay, and you're looking up at the moon. So you have to understand, okay, when the moon is in between the sun and the earth, and I'm looking at the moon, it's a new moon because of its position. The new moon is always in between the sun and the earth. And when you look up at the moon, you see zero illumination, so there's no moon. Okay, going over to image 4, same thing. Now you have the sun, the earth, and now the moon is behind the earth. When the moon is behind the earth, you see a full moon. It's 100% illumination because the sun's light is being reflected off the moon. Okay, so in this position, again, when the moon is behind the earth, you see a full moon. In position 3, what you have here is a 90-degree angle. So in this position, you would say, okay, I need to go counterclockwise. So going this way, when I'm at a 90-degree angle, this is going to be a first quarter. So you would see light on the right and half the moon would be illuminated. Here in this position, a little bit difficult here, but you can see she's not at a 90-degree angle. Okay, so she's just after that third quarter because we're doing a counterclockwise revolution. So she's just past that last quarter or the third quarter. So then she would be a waning crescent in this position. And you would just describe your answers here in a text box. Here we're going to demonstrate and predict the sequence of events in the lunar cycle. A student viewed the moon through binoculars 1 week after a new moon. Which image shows the phase of the moon that the student observed? So if the student is observing a new moon 1 week from a new moon, you would be a first quarter. So then we have to decide which image down here is reflecting a first quarter. So for a quarter moon will be half of the moon. And so since it's first quarter, we're looking for the light on the right. So D would be the correct answer there. So after a new moon, okay, you would see a 1 week later, a first quarter. Okay, going here to slide 7, we're going to drag and drop the diagrams in the table below to match each diagram as a spring or a neap tide. So spring tides are when you have a straight line. So spring tides, spring starts with an S and so does the word straight. So spring tide straight line, I'm going to look for my images where I have the sun, the earth, and the moon in a straight line. And then here I also see a spring tide straight line. So when I have a spring tide, what you have is the position of the sun, the earth, and the moon in a straight line. So both the gravitational pull of the sun and the moon are pulling on Earth's ocean waters. So during a spring tide, you're going to have the highest high tides and the lowest low tides. Okay, so you're going to have a great difference between your tidal ranges, high and low tide. Same down in this position. So you have the moon pulling on Earth's ocean water as well as the sun's gravitational pull. And you have a spring tide, so you're going to have very, very high tides and then very low tides. So spring tides, straight line, the greatest difference between tidal ranges. Now neap tides, neap starts with an N and so does the word 90. So when you have the sun, the earth, and the moon in 90-degree angles, we call those neap tides. So I'm going to pull both my neap tides over here and then explain what those mean. So during a neap tide, you have the moon pulling on Earth's ocean waters and the sun, but they're in different directions. So this is where you're going to have the least effect between tidal ranges. So pretty much there's not a real big difference between high and low tide. And same here, you have the moon's gravitational pull working in one direction and then the sun in the other. So you do not have a great difference between tidal ranges. Okay, and then going over here to our drag and drops with our cards, we're going to have a look at these. Okay, so for a spring tide, you see spring tide straight line. This always occurs in the new moon phase or the full moon phase because that's when the sun, the moon, and the earth are in the straight line. Okay. In a neap tide, the phase of the moon that you would see would be a first quarter, because remember, you always go counterclockwise. So here's your first quarter, and then in your third quarter position or your last quarter position would give you those 90-degree angles. So let's drag and drop some of these boxes, either as a spring tide or a neap tide, to match. So the greatest difference between high and low tides is going to be a spring tide. Remember, that's going to be the greatest difference between your tidal ranges. So you're going to see a big difference between high and low tides. You're going to have super high tides and super low tides. So just the opposite, we can say neap tides are going to be the least difference between low and high tides. Okay, I'm just going to have, try to increase so you can see that a little bit better. Okay. And then coming over here, let's look at these descriptors. Sun, moon, and earth are in a straight line pulling on Earth's water in the same direction. Okay, so we can leave those there. Occurs during the first and last moons. So during the first and last moons, they're trying to say first quarter and last quarter. Okay. Occurs during the new moon and the full moon. So new moon and full moon would be your positions here. And then the sun, moon, and earth are in right angles pulling on Earth's waters. And lastly, we're going to look at a STAAR test question. It says, different relative positions of the sun, the moon, and the earth have different effects on Earth's oceans. Which model shows the position of the sun, the moon, and the earth that have the greatest effect on ocean tides? So remember, the greatest effect on ocean tides, the greatest difference between tidal ranges is going to be your spring tides. So looking down below, which model do you see a spring tide straight line? So D is indicating that spring tide straight line where you're going to have the greatest effect on ocean tides. You're going to have very high tides and very low tides.